Good day everyone. So for today's video, we will gonna tackle about what is silicon controlled rectifier and what is the uses of it and what are the three terminal of it. After that, we'll test the SCR by using the software and I'm multi-teasing. So what are we waiting for? Let's start the video.
Yeah, I need my money raw. Yeah, I'm looking at the bank statements. I do not want to jail. Yeah, nuts with my gang. You be just a stain. Cover on my chain.
So what is silicon controlled rectifier? A silicon controlled rectifier or semiconductor controlled rectifier is a 4-layer solid state current controlling device. The name silicon controlled rectifier is General Electric's trade name for a type of thyristor. The principle of 4-layer PNPN switching was developed by Moll, Tannenbaum, Golday, and Holonyuk of Bell Laboratories in 1956. The SCRs are mainly used in devices where the control of high power, possibly coupled with high voltage, is demanded. There are three terminals of SCR, namely anode, cathode, and gate. So that's it. Let's test the SCR by using multi-teasing.
So here in schematic diagram, we have 12 volts power supply, and also we connect the 20 k ohms potentiometer, and then we have a jumper from the potentiometer to the upper part where is the 470 ohms resistor, and the lower part the 20 k ohms resistor. We have also a jumper, and from R1 470 ohms resistor to LED we also have a jumper, and also in the lower part the 20 k ohms we have a jumper to from the ohms to SCR and then to ground. And
So here in our first kinematic diagram, we could conclude that the potentiometer controlled the current through the circuit. If we adjust the potentiometer in a certain value, like 5%, 10%, 20, 30%, 40, and even 50 and 60%, the lead will not turn on, since the current from R3 not reach the minimum voltage that the gate needed for the SCR to switch on. So the SCR here acts like a switch. But if you adjust the potentiometer value to 70% or even higher, like 100%, the lead light will automatically turn on, because the current from R3 to R2 through the gate exceeds what we call the holding current. And we have also observed that if you lower the value of the potentiometer from 100% to 5% or even 0%, the lead will not turn off. It is because the gate can only trigger the SCR to turn on. It cannot switch it off. Alternatively, the SCR will only turn off if you apply a negative voltage to the anode of the SCR.
Good morning, sir. I will explain what are in the circuit of silicon controlled rectifier. Nag-compose ni siya of resistor, transistor, inductors, capacitor, o diodes connected by conductive wire. Resistor is a current na mo limit sa device or considered a passive device. May magpadagan sa kanang kurente. Transistor is an electronic component that can act both amplifier and switch. Capacitor is mo store sa electrical energy na mudagan. O ganing inductors is a simple coil of electrical wire around a core of magnetic material which store energy in a form of magnetic field. Para to, sir. Thank you.
So in the schematic diagram 2B, there are two switches added. the normally open switch and the normally closed switch, which is replacement of for the potentiometer. So the normally open switch is connected to the gate, while the normally closed is connected to the anode and cathode of the SCR. So let's test the circuit if how this works. So if we switch our normally open switch, the LED will turn on. But if we turn off our normally open, the LED will not turn on. It is because the gate can only trigger or switch on the SCR. It cannot be switched off. Alternatively, the SCR can be switched off by using the two-way of turning off the SCR, which is the anode current interruption and the force commutation. So as we can see in the circuit, we use the force commutation. So the force commutation is a method basically requires momentarily forcing current through the SCR in the direction of the opposite to the forward conduction so that the net forward current is reduced below the holding value. So if we turning off the normally closed, the LED will turn off. So that's how the SCR works. So that's all for today. Hope you learned something and see you on our next video.